In this lesson, we're going to do 3x3 systems, both by elimination and Cramer's rule. This is lesson chapter 3, section 4. We're going to talk about Cramer's rule, and we're going to talk about elimination to solve 3x3 systems. Right. So the key part here is we got 3 variable systems. All right. So from your homework, we're going to do number 13, because on the handout on the odds, I want you to do the elimination method, and on the evens, I want you to do Cramer's rule. But with 13, here's our system. Okay, let's see, negative x plus y minus z equals 2. I want to make sure I don't copy it wrong. 5x plus 2y plus 10z equals 39. Okay, since you have 3 variables, in order to use elimination method, you're going to have to basically do elimination 3 times in most cases. And you're going to have to do elimination with the top 2. So I'm going to put that over here. And you're going to have to do elimination with the bottom 2. So that middle function, you just repeat it. And the whole goal is to eliminate the same variable so that you have a system of 2 variables. So with this, again, the way that I look at 13, right, I don't even have to multiply anything right away. The z's are going to eliminate, and now I have a function of x and y. So since I eliminated z automatically with the top 2, I will need to do the same for the bottom 2. I need to eliminate z. So to do that, I'm going to make it negative 10 by multiplying it by 10. So I'm going to rewrite this as negative 10x plus 10y minus 10z equals 20. Okay, so that function is now this function. I'm going to add those up. Now I have negative 5x plus 12y equals 59. And then, so there's elimination twice. Now we're going to do it one more time to finally get an answer. So these two, I'm going to write them on top of each other here. So it's, and then this one. And the way that I see it here, since I only have to, I could get opposite 10x's, but I'm going to get opposite y's by multiplying the bottom by 12. Okay, so now that becomes 24x minus 12y equals 36. So I'm going to add up those two, and now I'm at positive 19. And 59 plus 36, 69, 70, 89, 95. So when I divide by 19, we get 5. All right, so now we finally got an answer. So now I'm going to just back substitute to get my other 2 variables. Doesn't matter which one you pick. Just pick a function that has 2 variables. One of the variables being x, so that you can solve for the other variable. So I'm going to pick the top. So now I'm just left with one variable which I can solve for. So I'm going to add 25. So that's going to be 69, 79, 84. And 12 goes into 84. 12 times 5 is 60. Then we have 72, 84. Okay, so 7 times. Okay, so now I know that one. Now I just go all the way back to the top to find z. Okay, so I'm going to use this one here. It doesn't matter which one you use though. So I have negative 5 plus 7 minus z equals 2. So now I have 2 minus z, subtract 2, and then divide by -1, still 0. So then you're done. You can always take and plug those back into your original 3 functions to make sure that, so you can check your work up here to make sure that it works. So that's elimination. Now, we can also solve systems by Cramer's rule. So Cramer's rule uses matrices to solve a system. First of all, just a little review about what a matrix is. Okay, it is a group of elements. So these are usually numbered, or are always numbers. Sometimes they can be variables too, but we call these elements. Okay, and one thing I want to get consistent the first time we talked about matrices. Okay, your dimensions is always row by column. Matrices is just one avenue to solve systems, but we can use matrices for numerous of reasons mathematically. But Cramer's rule, here we go. So in other words, this is a 2 by 3 matrix. We have 2 rows and 3 columns. Now, the way the matrix or Cramer's rule says is this. Okay, so I'm going to star this. It says the value of x is going to equal the determinant of matrix dx divided by the matrix of D. All right, so again, those are not absolute value symbols, so this is something else that is new. It's called the determinant. Okay, and then y is the determinant of y over the determinant of matrix D. And z is equal to the determinant of matrix dz over the determinant of matrix D. So I have to teach you what a determinant is and what each one of these matrices are. Okay. To do that, we're going to use example number 12. So here's the system. So 3x minus y plus 2z equals 3, and negative x plus 3y plus z equals 6. Okay, now what matrix D is we call it the coefficient matrix. So what we have here, or you just take all the coefficients, so the coefficient of x is 1, 3, negative 1. So the numbers in front of the x variables is that. And the second column is coefficients of the y's, which is 2, negative 1, 3. And the coefficients of z is negative 1, 2, and 1. Now, if I want to find its determinant, here's what we do. All right, first, we're going to change our symbols to non-brackets, and we have these absolute value looking symbols to stand for determinant. And to calculate the determinant of a 3 by 3 matrix, we copy it down, plus we have to rewrite the first 2 columns. And then we multiply the diagonals left to right, diagonals that have 3 numbers in them. So the ones that have 2 we ignore. So that 1 times negative 1 times negative 1 is negative 1. 2 times 2 is 4, times negative 1 is negative 4. Negative 1 times 3 is negative 9. So the key here is do the product of the diagonals left to right first, minus the product of the diagonals right to left. So now we're going to go this way. 2 times 3 times 1, 6. 1 times 2 times 3. And negative 1 times negative 1 times negative 1. And we get, so we have negative 14 minus 11, which is negative 25. So that is what the determinant of D, matrix D is. So if we go back up to the Cramer's rule, that's going to be the bottom number in all of these. So what is matrix dx and matrix dy and matrix dz? Okay, first of all, if we want to do matrix dx, what you need to understand is that we take these constants, all right, so the numbers without a variable, okay, and we're going to replace the coefficients, okay, of the determinant variable, whatever variable determinant I'm making. So here I'm going to take the x coefficients and I'm going to replace 4, 3, 6 there. Everything else will stay the same. So then y, my 4, 3, 6 will go in place of the y coefficients, and 4, 3, 6 will go in place of the z coefficients. And then everything else stays the same. Okay, so still have my coefficients of x, still have my coefficients of z, still have my coefficients of x, still have my coefficients of y. And then when I do those determinants, okay, well, I'm going to then copy the first two columns. So now if I change this, okay, so now I want the determinant of x. Well, the determinant of x just means I'm going to repeat the first two columns. So 4, 3, 6, 2, -1, 3. And then I'm going to do as I did before. Same thing with these. So, want the determinant of y. You're going to repeat the first two columns. So it's here 1, 3, -1, 4, 3, 6. Here would be 1, 3, -1, 2, -1, 3. And determinant of z. Okay? And then those are going to be the top numbers as far as Cramer rule goes. All right, so left to right, 4 times -1 times 1 is -4. 2 times 2 times 6 is 24. -1 times 3 times 3 is -9. This way, 1 times 3 times 2. 3 times 2 times 4. 6 times -1 times -1. Okay. And with that, I'm just going to come over here. -4 plus 20 is 20, minus 9 is 11, minus 36. So that's also -25. So the determinant of x is also -25. So that means x is just going to be 1, because -25 divided by -25 is +1. We'll do the same thing for these rest. All right. So here I have 3, -8, -18. And this way, I have 12, another 12, and a +3. So now I have -5 minus 18, which would be -23, and 27, which is -50. So I come up here, -50, -50 divided by -25 is +2. So x is 1, y is 2, and now we have one more. So z. So again, we're going to go, okay, it's not, my diagonals aren't very good on that one. Okay, 1 times -1 times 6 is -6. 2 times 3 times -1 is a -6. 4 times 3 times 3 is 36. Positive. Go this way. All right, so now I got 2 times 3 times 6. 3 times 3 times 1. And then -1 times -1 times 4. So -12 plus 36 is 24. And 36 plus 9 is 45 plus 4 is 49. And then that's also -25. Put that up here. Z is 1. So with that, we know this the solution. X is 1, Y is 2, and Z is 1. And you can go back and plug that back in to see if they all work, just like you could with any system. You can always check to make sure it works. So again, I want you to do the evens using Cramer's rule, and then the odds, I want you to use elimination.